This video is going to continue looking at Chapter 10, Triangle Trigonometry, and we're going to continue looking at oblique triangles and solving oblique triangles. We are going to go back and look at our flowchart for solving trig problems because we're going to do something a little bit different. For 10, I believe it was 10.2 and 10.3, we really focused on right triangles. So when it says, is the triangle a right triangle? We're not going to go this route because we've already gone there. And then, so we're going to look at triangles that aren't right triangles and triangles that we know the opposite, but we don't know the opposite angle from a side. So we can't use the sine rule. So what we are going to look at is we're going to look at oblique triangles that we don't know the angle in the opposite side, and then we're going to use the cosine rule. So we're going to talk a little bit about the cosine rule and introduce you to the cosine rule first. And so the law of cosines is going to give us two new cases. So we had case 1 and case 2 that we've already been able to look at with the law of sines. Case 3 and case 4 are going to involve problems where you are given a problem that you only have, in case 3, two sides and the angle included by them. And so what that's going to look like is we're given two sides and the angle that is included by them. Remember that case 2 was two sides and an angle that was opposite angle from it. And so this is a little bit different here. And case 4 is where you're given all four sides. Excuse me, all three sides. Sorry, it's getting late on my recording. And so now one of the things you might want to do is jump right in and say, hey, I can use Pythagorean theorem. But remember, you can't, because this is not a right triangle. It is an oblique triangle. One thing I do want to make sure to correct as I'm looking at these formulas for finding sides and formulas for finding angles, I'm going to explain to you about them real quick, but I want to make sure and have a correction. That is supposed to be squared right there, and it is not. So I bet every single one of these where this is in there, that is not squared. So I'll try to make sure to remember to square it every single time and to change that on the formula sheet. If not, make sure that you have the correct one and that you square that. So looking at this is the law of cosines. I want to make sure that everybody understands that these are really the same thing. So this formula on the left is for finding the side of the triangle, so side A. And the formula on the right is for finding angle A. It's the same formula, it's just rewritten differently. So if you play around with it and you move the numerator and denominator and you use your rules for being able to move a formula around, you'll see that it's actually the same formula. But it's handy because when you're looking for finding the side A over here, when you have it over here isolated by itself, all you have to do is take the square root. And when you're looking at finding the angle A, it's a lot easier for finding the cosine A and then just finding the inverse cosine for that, so you can get the angle. Same can be said for finding angle B and side B, as well as finding angle C and side C. All right, we'll make sure to update that formula sheet on every single one of these. All right, let's look and see how we can go ahead and utilize these. And forgot to bring up my little screen here, so it kind of gave some of it away maybe, but that's okay. Let's see how we can solve this. So we want to run through the flow chart like we do every time. So in case you're given this as a problem on a test and you're not given any context, you say, okay, is it a is it a right angle? No, not that it looks like it, or at least I can't tell. Certainly the picture isn't a right angle. So Do you know a side and its opposite angle? All right, well, let's see. I know a side. We're given a side. Matter of fact, we're given two sides. And so we have a side here and a side here. And the angle is here, but it's not an opposite. It's actually an inner. It's inside of both of those angles. So, or both of those sides are adjacent to that angle. So, no, it is not. Does not fit that rule of a side and opposite angle. Okay, so that means that we're going to use the law of cosines. So let's go ahead and try to figure this out then, and given what we've got, I'm changing my formula sheet. Okay, so if we're given this problem and we want to be able to try to figure it out, let me pull this down here. We want to use the law of cosines, so we need to start somewhere. And so one of the things that we can do is we can see that, all right, we have side A and we have side B. We don't have side C, but we do have the opposite angle, and that's sine C, or angle C, which we can get sine C. So let's go ahead and do that. So let's use this formula right here, where we're going to be looking for C. And hopefully my pen isn't going to freak out again. Okay, so let's go ahead then, and we're going to plug everything in as we go. We're going to say C squared. Oh, spoke too soon. Whew. Sorry, folks. So C squared equals A squared, and in this case, A is 22.8 squared. Remember, A is opposite. That's an A, not a 9. Opposite its angle, and same thing for B. It's opposite its angle. Okay, so 22.8 squared, and continuing on with the formula, so C squared equals 22.8 squared plus B squared, which is 12.3 squared, minus 2 times A, which is 22.8, times B, which is 12.3, times cosine of cosine of C, which is going to be cosine of 42. Okay, now it's just plug and chug. So don't let all those numbers kind of get you. It's okay. It's just a longer formula. Anybody who's had to do some of the, who did the last math class will remember how much fun some of these formulas are. So let's go ahead and get 22.48 squared. So C squared equals 505.3504 plus 12.03 squared, 12.3 squared, not 03 squared, 151.29. This is one thing to caution you on, though, and that is to make sure to be aware of your signs and making sure you're plugging things into your calculator. Sometimes those transposition errors or calculator errors can be they can be deadly and really affect what you are doing. And so we're going to go ahead and calculate up the next part then. And so 2 times 22.8 times 12.3 times 42, and cosine. Remember, if you're getting used to, if you've been doing sine, using the sine formula, make sure that you're using sine laws, that you remember that this is cosine. And then we will get on this side, so minus 416.82. Okay, so let's go ahead and figure this out then. Now we have 505.3504 plus 151.29 minus 416.82, and we get 239. C squared is 239.8204. And so to get C, we need to take the square root of that. And we will come up with C is 15.49. And this is in centimeters. Okay, let's go back and make sure that this looks like that might make sense for our triangle. And yeah, that would make sense. So 15, that's not good. Don't know what causes that. 15.49 centimeters is C. Okay, so now remember the directions for this problem were to solve the triangle. So in order to be able to solve the triangle, then now we need to make sure to solve, make sure we get our inner angles, and we should be able to do that now that we have that we've got another side here. And so we can take a look at this side, and we can go ahead and try to figure out what cosine A would be. And so we'll just go ahead and do that. And get resituated here. And, I'm thinking about it just in case. Sure, it's got a square on it. Okay, so let's go ahead and figure out cosine A. We're going to figure out right in there, since we have the two sides on either side of it, right? And so we'll go ahead and use our cosine A formula from right over here. And we'll say cosine A equals B 12.3 squared plus C squared, which we now know, 15.49 squared, minus A squared, which is 22.8 squared, over 2 times B 0.3 times C, which is 15.49. Sorry, I got distracted looking off somewhere else. Okay, so again, now it's just time to plug and chug on this and try to figure out what the cosine of A is. And so to be able to do that, we'll go 12.3 squared -hmm. 151.29 plus 15.49 squared, which we can actually come back up here and just look at, I believe. No, that's right, because we didn't have C yet. So let's see, 0.49 squared, 239.9401 minus 22.8 squared, which we do have, and that is 505. 0.3504. If you guys are wondering, this is where I'm getting this stuff up from up there. So already figured it out. No need to do it again. And then 2 times 12.3 times 15.49. 2 times 12.3 times 0.49. 381.054. 381.054. If anybody wants to, on their comment sheet for the semester class, say that I need a better writing material or better something to be able to write on for these distance ed classes, maybe they'll buy me one. So that would be great. All right, so let's see. Let's go ahead then and we'll finish the rest of this. So cosine A, let's see, 151, 1.29 plus 239.9401 minus 505.3504 gives me negative 114.1203 over 381.054. So we'll take that and we will divide it by 381.054, and we get cosine A equals negative 0.299. And when we go to find our inverse, remember it's inverse cosine, not inverse sine, then we get 107. And that 107 goes right here, 107 degrees. Okay, so now let's go ahead then, and we are looking at only one more angle that we need, and that angle is angle B, and we know that what we can do is say that we have that the inside theorem of a triangle says that, just to cut across there, is that 180 degrees minus the 42 degrees for angle C and minus the 107 degrees for angle A, that we have 31 degrees. For angle B. And that is the way to complete the triangle.